Hi there. Let us solve for the zeros of the polynomial function 2x cubed minus 5x squared minus 28x plus 15. Let us apply the rational root theorem and the fundamental theorem of algebra. So we start by noting what is the degree of the polynomial, and that is 3. By the fundamental theorem of algebra, the number of zeros is equal to the degree of the polynomial. Thus, n equals 3 would suggest that we are going to look for 3 zeros of the function. We also take note of the constant term of the polynomial as denoted by a sub 0, and that is 15. We also note the leading coefficient, which is 2. We get all the factors of the constant term and write it under the piece. Write the factors in ascending manner and an organized manner such that we will not be missing anything. So we have plus or minus 1, plus and minus 3, plus and minus 5, and plus and minus 15, considering that 1 times 15 is 15, negative 1 times negative 15 is 15, 3 times 5 is 15, negative 3 times 5 is negative 3 times negative 5 is 15. The factors of the leading coefficient is also termed as Q. And what are the factors of 2? Plus and minus 1, plus and minus 2. Considering this, we have to write down all the different possible rational zeros. And what are these? The possible rational zeros are actually the P divided by Q. So each of the P's should be divided by each of the Q's. Let's list them down. 1 divided by 1, I will no longer say plus and minus. I'm just going to write plus and minus 1. 3 divided by 1 is plus and minus 3. 5 divided by 1, 5. Then we have 15 divided by 1 is 15. We also have to consider dividing all the p's by 2. So 1 divided by 2 plus and minus 1 half. 3 divided by 2 plus and minus 3 halves. 5 divided by 2 plus and minus 5 halves. And 15 divided by 2 is plus and minus 15. Cannot be contained. So I just write that down. So we have plus and minus 5 halves. And then plus and minus 15 halves. These are all the different possible or the possible rational zeros, but we are only looking for 3. Which of these possibilities are the zeros of the p of x? We have to consider again that if p of p divided by q is equal to 0, that is the only time that we can say that p divided by q is a zero of p of x. So we start evaluating, or we can also make use of synthetic solution. We start evaluating the p of x with any of the p divided by q. Let us write first for our guide the function 2x cubed minus 5x squared minus 28x plus 15. We start by evaluating the polynomial, changing the x with the first value of p divided by q, which is 1. So we have 2 times 1 cubed minus 5 times 1 squared minus 28 times 1 plus 15. And knowing that any number multiplied by 1 is the number itself, and 1 raised to any exponent is 1, we have 2 minus 5 is negative 3, minus 28 is a negative 31, plus 15 is a negative 16. And we did not arrive at a zero value, so our conclusion will be that 1 is not a zero of p of x. There. So we check for the next value. We check negative 1. So we replace all the x's with a negative 1. Thus, we have 2 times negative 1 raised to 3 minus 5 times negative 1 raised to 2 minus 28 times negative 1 plus 15. Well, of course, you can make use of your calculator to facilitate the solution. Or, we now have here 2. When you raise negative 1 to an odd exponent, it remains to be negative. While if you raise to an even number, that would be positive. Then negative 28 times negative 1 is a positive 28 and plus 15. Thus, we will be arriving at 2 times negative 1 is negative 2, then minus 5 plus 28 plus 15. And simplifying this one, we will be arriving at a value which is 36. Since again, we came up with the value of p of negative 1 to be 36, then our conclusion will be negative 1 is not a zero of the p of x. Let's also check on the next value, and that is 3. So p of 3, so we now have, well, we can make use also of synthetic solution. Okay? So let's do that. Let's make use of synthetic solution. So we have 2, negative 5, negative 28, positive 15. And what are we checking? That is 3. So we have, bring down 2. 2 times 3 is 6. Then negative 5 plus 6 is a positive 1. Positive 1 times 3 is a 3. Negative 28 plus 3 is a negative 25. And a negative 25 times 3 is a negative 75, leaving us with a negative 60 as a remainder. So since the remainder is negative 60 by the remainder theorem, then P of 3 is also a negative 60. So from here, we can again conclude that 3 is not a 0. Well, we continue to check. What is the next that we have to check? Let's also say negative 3. Let's check for the negative 3. So what is P of negative 3? Or we can make use of, again, synthetic solution. Let's see. So we still have the first row to be 2, negative 5, negative 28, and 15. What are we checking? Negative 3. Thus we have 2. 2 times negative 3 is a negative 6. Negative 5 and a negative 6, we have a negative 11. Negative 11 times negative 3 is a positive 33, plus a negative 28 is a 5, times negative 3 is a negative 15. And yes, we have a remainder which is equivalent to 0. And again, by the remainder theorem, p of negative 3 is 0. With this, we have solved one of the zeros, and we say that negative 3 is a zero of p of x. Thus, we have already one of the zeros. What are the other values that we have to check? Since this is the first example, let us all check by evaluation or by synthetic solution. We also have a 5. We check also the 5. So we now have P of 5. Again, let's check making use of synthetic solution. So we're checking 5. Thus we have 2, negative 5, negative 28, 15. Then we have 2. 2 times 5 is 10. Negative 5 and 10 will give us a 5. 5 times 5 is 25. Negative 28 plus 25 is a negative 3. Negative 3 times 5 is a negative 15, giving us a remainder of 0. Since the remainder is 0, we can also say that P of 5 is equal to 0. Thus, our conclusion, 5 is a 0 of p of x. Okay, let's check the next one. Say we're also going to check for 1/2. So we check for 1/2, p of 1/2. By evaluation or by synthetic, let's do it by synthetic. So that's 1/2, and we have still the first row 2, -5, -28, 15. So that we now have 2. So 2 divided by 2, that's the denominator. It's 1 times 1 will give us a 1. -5 plus 1 is a 4. Then 4 divided by 2 is 2 times 1 is a 2. Then we now have -28 plus 2 is a -26. And then we have, oops, I have an error somewhere. Okay, there. -5 plus 1 is a -4. And a -4 divided by 2 is a -2 times 1 is a -2. And -28 plus a -2 is a -30. And what is 1/2 of -30? Again, we have here -15 plus a 15 plus -15 is a 0. We have here again a remainder of 0, telling us that p of 1 is equal to 0. So what is our conclusion? We now have here 1/2 is a 0 of p of x. So how many have we solved already? We have 3 is a 0, 5 is a 0, 1/2 is a 0. And if we go back to our thinking a while ago, since n is equal to 0, there are 3 zeros for the polynomial function, and we were able to arrive and we were able to solve for the zeros. And in conclusion, we now say that the zeros of p of x being 2x cubed minus 5x squared minus 28x plus 15 are what we have solved there. We have -3, 5, and 1/2. So that is how we solve for the zeros of a polynomial function. In the next video, we will be having the depressed solution, which is now an easier way and a shorter way of coming up or solving for the zeros of p of x. Thank you for listening and thank you for watching. See you in the next video.